afternoon, good evening, and good morning to everyone who's tuning in to this live stream. I'm pretty sure like all of you are there present in different parts of the world, but all of us have like gathered here today to learn from Matthew on how to create a backend service using the Go language. So before starting off with the live stream, I just want to let Matthew know that people are from all around the world are here to come watch him, create something live for us here. So wherever you're tuning in from, you can drop in the name of the country. So I am from India, so I would write India, and sorry, drop in the name of your city. So if I'm from Bangalore right now, so I will write Bangalore, India. So just like that, whichever city you're tuning in from, just drop the name of the city, and then Matthew will know that people from all around the world have come to watch him live today. So yes, Matthew, how excited are you? Like, or how nervous are you feeling right now?
I'm more excited than nervous. I really enjoy doing this kind of thing. I enjoy interacting with people across the world. This is one of my favorite things to be able to do, and I really appreciate you giving me the opportunity to do this today.
Right. So we already have people tuning in. So there are people from Meerut, that's in India. We have people from Delhi, Jharkhand, Mumbai, India, Noida. A lot of people from India though. But like I'm pretty sure like people from all around the world are here. So if you're free or from anywhere else, you can also drop in. Okay, so they're coming in. Okay. So people from Iraq, from Florida, all of you want to say hi to you. So Soumya Ranjan is telling you hi.
Hello, everybody, wherever you are.
Right. So we have people from New York, Kashmir, Pune, South Africa. So yeah, I mean, I think you get a gist of like a lot of people have tuned in today. So I hope that makes you a little more nervous, uh but it shouldn't. I know you will like ace it. So
Yeah, no, I'm not so sure. You're making me anxious.
okay, so let's start with the live stream. But before that, like let me just introduce Matthew first. So our guest for today, All Star Matthew, is an all star in the true sense of the term. He's an engineering team lead at Yext. He's an organizer of DevOps Days. He's the founder of NYC Coffee Ops and an amazing speaker and mentor. He's very proficient in the Go language, and he has also written a book titled Cloud Native Go, which was published by O'Reilly Media, and he has previous experience working in companies like Flatiron, and Coinbase. And we are sure that we have so much that we can learn from him today because he has such a varied experience and um, he has a lot of knowledge. And I'm pretty sure all of us are ready to absorb all the knowledge that you give us today. He loves to teach, and that's what he's here for. He's going to teach us how to create a backend service using Go. So, Matthew, welcome to the live stream, and we are very excited to learn from you today.
Thank you so much. I'm really excited to be here. So, all right, is my are my slides visible yet? My screen visible?
Yes.
Perfect. Excellent. All right. First, good morning, good afternoon, good evening, wherever you are. Again, my name is Matthew Titmus. I am an engineering lead for the SRE team at a company called Yext. Formerly, I've been at Coinbase, Flatiron Health. I'm an organizer for the DevOpsDays conference in New York City. Founder of the NYC Coffee Ops Meetup, which boasts about 1,200 members, and author of a little thing that didn't take me a year and a half at all, called Cloud Native Go, which is a good book, I think. So please go out and buy it and enjoy it. First thing I'm going to do is, well, let me first tell you there's a GitHub repo for all the examples that I'm going to go over. It's not huge. I think there are 5 directories with the 5 sections that we're going to go over. If you want to play along, so to speak, go ahead and you can clone that repo. Secondarily, I'd like to also make sure that everyone feels free to ask questions at any time. Don't worry about interrupting. As a rule of thumb, I know the questions are going to be screened for the most part, and the interruptions will come at whenever seems like a good gap. But please don't worry about interrupting. Ask whatever may be on your mind. So again, ask questions at any time. So the things we're going to go over, we're going to take things pretty simple today. So first, we're going to talk about the super simple API, the core of our service. what it really looks like and fundamentally what it really is, if you don't worry about all the methods and everything on the outside. Second, we're going to talk about building handler functions, which is an aspect of the net HTTP library. Then we're going to build on that and actually build a really small HTTP server. We're going to extend on that with the Gorilla Mux Go library, which builds on top of the net HTTP core library. And from there, we'll go on to actually build a full-fledged RESTful service. And hopefully, you'll get some stuff out of this. Hopefully, you'll see that Go is a really good language for this kind of thing. And I hope you find it valuable.
Hey,
So,
Matthew, so like before we proceed with the slides, I would like to like just say a few things. So
hmm.
this session will be recorded, so any of you can like come back on LinkedIn, YouTube, and then like watch this live stream again because he'll be coding live. So it's difficult to follow. So you can probably absorb knowledge right now, and then probably come back later and then follow along if you want to, or you can follow along right now as well if you're comfortable with that. And also, like you were speaking about like why Go would be a good language for this. So a
Mhm.
question that comes to my mind would be like a lot of other languages are quite famous, like C++, Java,
Mhm.
Python, and those are the languages that you hear of very often. But you have written a book in this language too. But so can you tell us more about why Go is your preferred language, and like why other people can also look at Go, and then like what benefits do you think it adds over to other languages for you?
Well, it's very true that when you're looking at programming languages, you want to use the right tool for the right job. Um, Go is a really good choice for a lot of the kinds of services that we kind of the global we build an awful lot of, specifically network enabled services of some form or fashion that are handling a lot of requests, services, in other words. Um, Go was designed to be very, very simple and to be very, very scalable along every possible access that you can really consider when it comes to programming languages. Um, it's eminently maintainable because it doesn't have an awful lot of magic in the language, which I consider to be a feature. It is really easy to work with. It's very, very fast. It does concurrency brilliantly. If you are working with an awful lot of requests and have a high request load for your service, you could have the option of building, say, a single service in Go that can handle 800,000 requests a second, or you can build it in something like uh, Python. Not that Python's a bad language; it's not a bad language, but it's an example of a slower language that can handle just a fraction of that number of requests per unit time.
Right.
So
Okay, that makes sense. I'm pretty sure like there must be other people who are new to Go as well, like in the audience today. But Matthew is going to make it really easy for all of us to understand. So yeah, Matthew, we can proceed further.
great, thank you so much. So what we're going to be building today is a really, really, really simple key value store. Something like a Redis or something like that, but way simpler. Essentially, it's going to look a little like this. We'll have a network, which could be any network you like. Localhost is what we're going to be working with. And there'll be a service wrapped around a map. That's it. That's essentially all it is. You will be able to put key value pairs into the key value store, retrieve them back, and then delete them if you wish. Very, very, very straightforward, conceptually pretty simple. We're not going to worry about distributed computation or distributed programming at this point. This is a single instance. If we need to start considering things like high concurrency, like distribution, those are advanced topics we can cover another time. But for now, we're going to start very simple. So this is what our simple core API is going to look like. This is not the service. This is what the service is going to be using. So what we have here, and I'll go actually to the original code itself. This is in directory 01 on the repo. We have three functions here. So we have start with a put function that retrieves, takes a key and a value, and just puts it in the map. This is what a map looks like. The creation of a map looks like in Go. If you haven't seen that before, it just uses the make predefined function to make exactly this. And this says a map with a key type string, value type string. The get function, also pretty straightforward. It gets the key. It takes the key as a parameter, looks for that value in the map, and if it sees it, OK will be true, and it'll return the value. But if OK is false, it'll return this error. We have a predefined error up here, and we do that so we can refer to that error later on, and you'll see how we do that. And then delete is pretty straightforward as well too. It's just literally call delete with a key, and it removes that value from the map. That's the core, that's the kernel of everything we're going to be working around. Our service will be using this fundamentally. It will not be working with maps directly. So rather, it'll be using this little simple API that gives you more flexibility, maintainability, and decouples your service from your functionality. So, all right. We don't have any questions so far, right?
No, like nothing related to the code, but we had a question that was like something different. Like, do you want me to ask you?
Sure, it seems like a good pause.
Yeah, so it was recommended Golang frameworks, if you have any in your mind right now.
Yes, specifically, and I'll actually cover one going forward. A good framework for building web services is one called Gorilla Mux. That's the kind of the de facto standard for building web services in Go. It builds on top of, and I'll cover all this in a minute, builds on top of the Net HTTP core library, and it's compatible with the Go core libraries. But adds a lot of additional functionality. It's very, very useful, very, very powerful.
Right.
So.
I hope that was helpful. And if you have any other questions while Matthew's going through the code or like while going through the slides, you can ask them and I'll feature them on screen and then Matthew will answer it. Yes.
Okay, moving on to creating the handler function. A handler function, to define it, going back a little bit to a feature of Go that is very powerful, Go specifically allows what are called literal functions, where you can refer to a function as a variable. So you can have a variable that is also a function. An example is given on the screen here. We have a function we call reverse, and this is creating a literal function. So it's just a function without a name. We call it, we assign it to the reverse variable that takes a string and returns a string, and this just reverses the string. If we wanted to execute that as a function, we can execute it as if it were a regular function as well too. So in this case, we can print line, reverse, pass it the string foobar. When we run this, it does exactly as we would expect here. So this is a literal function in Go. What the value of this is it allows us to build functions that adhere to specific contracts. And we can say very easily then, okay, when you see a particular type of request, then handle it using this particular function. So rather than having to build interfaces or do all sorts of other kind of long walk stamp collecting kind of stuff like you'd have to do in Java or something like that, you can have a literal function and just pass it to another function. So this is the Net HTTP handler func contract. This is what it looks like. So a handler function just has to adhere to this pattern. This is the definition. So it just has to take a string. I'm sorry, handle func is, sorry, the handler function itself. It just has to take something called a response writer, which is in the HTTP package, and a request, which is also an HTTP package. Handle func is what we then pass along to the multiplexer, which I'll deal with in a minute. I'll show you what that means. But this is the assertion that we use to say that when you see this pattern, use this function. An example handler function looks like this. So here's a function called hello Go handler. If this function is called, it just writes out hello Gorilla Mux, which is which is the framework, a framework we're going to work with a little bit later. So I know that's not quite clear yet. I'll show you exactly what that means.
So we have a few questions.
Yes, please.
Right. So one question was, is it necessary to use a framework for backend in Go?
Absolutely not. Gorilla Mux does give you some things like you can insert variables into URIs. You can match on paths, and stuff like that. All sorts of nice functionality. But if you're writing a fairly simple service, there's absolutely no reason you have to use a framework. Go has a very rich core library set, standard library set, covering virtually any functionality you could really want, including their HTTP clients and services libraries. There's no reason you have to use a framework at all. You can build right off of the core library if you want to.
Right. And another question that we have here is, which ORM is best suited for Go development?
That is that's a question of opinion.
Right.
The reason I'm taking my time answering this is because that is a matter of some religious debate almost. I use what is there? Visual Studio Code is the one I use, which I like quite a bit. There's I can't remember what the other ones are called. There's like Golang. There's a couple of others. But ultimately, the one that is the best is the one that you're most comfortable with. There's no real extensive support for the language necessary by any one particular kind of interface.
Right. Yep, I think we can move forward now.
Okay. Great. All right. So handler functions. Let me show you then what this looks like. Here we have a handler function like the one I showed you before. Actually, this should not be Gorilla Mux. This should actually be net HTTP because we're not using Gorilla Mux here. So we have a handler. This is a handler function. It is it's a function. We can refer to it literally by name. We're not calling this function. For calling this function would look like this, but we're not. We're referring to it simply by name. Right. So now we have the HTTP handle function that is part of the core HTTP library that we're referring to here. And that says whenever a request comes in on the root, we call this handler. And then we take this and we call listen and serve. Don't worry about the nil for now. You'll see what that means in a minute. But this uses the default serve mux handler. Mux is short for multiplexer. It's the thing that handles all the requests. So we pass the output to a log function so we can see the output. And then we call listen and serve. We're listening on port 8080. So if I were to then, this is in O2, here's our code. And if I run it, it's not going to say anything. That's to be expected. But if I were to curl this port, it'll say, well, I should probably save that before but it'll say hello net HTTP,
right.
Exactly as we expected. Now stop this. And again, this is in directory O2 of the Git repo. Now, Gorilla Mux is a framework that adds an awful lot of functionality to the core libraries. The core libraries are solid. But they're also very simple. They don't have a lot of bells and whistles. That's where Gorilla Mux comes in. It's the de facto standard for building RESTful services in Go. It has a lot of useful features. It's fully compatible with the net HTTP core library. Defines a custom multiplexer There's a link there if you want to take a look at it. It's very, very useful. Some of the functions, you can have variables in your URI paths. We'll see examples of that. We can use route matching such that the same request, a request to the same URI via a GET or via a POST can be handled by different methods if you so choose. Same thing with URL schemes or header values or query values. It allows for middleware, which we're not going to cover, but it's very, very interesting and very, very powerful. If you care about RESTful frameworks in Go, definitely look at it. It'll change your life. And many, many more things. We don't have the time to cover even a fraction of them really right now, but definitely take a look. The differences between using Gorilla Mux and NetHTTP are very, very small. See if you can spot the differences here, which you should be able to. They're highlighted in red and blue. Using the core library, we call directly into the HTTP package with the handle func. And then we call listen and serve and pass it nil. When we use Gorilla Mux, that provides a custom multiplexer, custom router, so to speak, where we create an instance of the Mux router using the Mux new router function. And we still call the handle func as we did before, but instead of calling it on HTTP, we call it on our new custom router. And then we pass that custom router along into listen and serve. So it's essentially the same functions. It's just a different target. So I'll show you what that looks like. And I believe that is going to be in, yes, here. So as you can see, we're creating our new Mux router. Handle func is exactly the same, except it has a different target. It's now targeting our new router. The hello Mux handler is exactly the same function. So we're passing it this literal function reference, and we're still calling listen and serve. And running it is trivial. Oh, this is something else I wanted to show. Using Go modules and third-party packages, if you haven't seen this before, you can initialize your module. So I have to use a name. That creates this mod file, which is empty right now. But then the Go mod tidy function looks at your code, figures out what packages are required, and automatically configures your mod file, which is your dependencies, should contain. So now we're ready to go. We can run this. Now we've run the code. This is in directory 03. And we can once again curl localhost 8080, which is what we're listening on. Hello, Gorilla Mux. Super, super simple. But this is more powerful than this.
So we have a few questions.
Please.
Right. So Vidya asks, what are some pros and cons of Drop Wizard Java-based API development against Go?
I'm not super simple. I'm not super familiar with Drop Wizard anymore. I used to code a lot of Java way back when, but programmatically, the differences between Go and Java are pretty stark in a lot of ways. They're both compiled languages. They're both very, very powerful. There's an awful lot of value to something like Java. Java does have the need for the runtime, so it does have a JVM that comes along with it. That can be a plus or a minus depending on what you're looking for, but it does add quite a bit of weight to your code. So, for example, if you are doing something like development for Kubernetes or some other container orchestration tool, you can build a container that has a Go binary that is a not self-executing, but a standalone binary that is, complete. Maybe it'll be the one that we just built. Could be. Let's actually take a look. This one here. comes out to 6 meg, right? If we built a container and we wanted to run Drop Wizard, we would need a JVM, and that would be 300 meg, something like that, 400 maybe. So the resulting runtimes, resulting binaries are far, far lighter, far, far more, far easier to move around, to download, especially in a system like, again, something like a Kubernetes or something like that. So it's much more appropriate for a cloud environment.
Right. So there's another question. Are there modules and internal libraries being maintained compared with other languages?
Modules and internal libraries being maintained compared with other languages? I'm not quite sure I understand the question.
I think they're asking about like, are the libraries being maintained for Go language, and then like you talked about how intense it is, right? Like how intensive it is, and it's a very powerful library. I think you
Yes.
mentioned that. So yeah.
The ecosystem around something like Python and something like Java are extremely rich. Python in particular has a very rich third-party ecosystem. Go does have a pretty solid third-party ecosystem with modules and libraries that you can use and interact with. It's more than sufficient to do pretty much anything you need to do. However, instead of 8 choices to do a single function, you'll have 1 or 2. But there is a library for pretty much anything you'll need to do.
Right. Yes, I think a lot of people are excited to learn Go. Like a lot of questions are coming in relating to Go, and people are going to pick up this language probably. So yeah, all thanks to you.
I appreciate that. It's a beautiful language. Do we have any more questions, or shall we
We
continue?
can move forward. Yes.
Great. So okay. To highlight some more of the functions that some of the functionality that the Gorilla Mux package provides, we have on the left, we have 3 different handler functions. We have a function that just returns the word hello get. We have one that just returns the string hello put, and then an echo handler that reads an argument, and I'll go over exactly how that works. Pulls an argument from the request and echoes that back. Now the main function, let me actually go over to the Go code and show that a little bit. I believe that should be, that's this here. So once again, we have 3 handler functions. These get passed to the router, the Mux router, down here in the main function. And we have these things here. So here we create the router, the Gorilla Mux router, as we have been. But you'll see there's something a little bit different here. So in this example, I'll put this on one line to make it a little easier to read. We have the handle func like we had before, but we have this thing here, which is a little bit weird. So what is that? That specifies a variable. So in fact, we don't even need this. I'm just going to pull that part off altogether because it's implied. So what this says is whenever you issue a request, a query to Livestream, and then have a word after that in the URI, that word you can read as word. So that's where this comes in. So here in the echo handler, which is the handler function for this particular pattern, we retrieve the variables from the request. It's just a map. And then we get the word. It's called word because that's what we called it here. And then we repeat it back. That's it. Nice and simple. That's one of the features that Gorilla Mux provides. I'll show you that in a second. Actually, I think I'll show you that now. So that's an 04. So I'm now running this. Now, if I want to do something like curl localhost 8080 and I wanted to go to, let me make this verbose. 8080 live stream. Ooh. So we can see this is verbose now. This is the full communication, the full handshake, the full exchange that went on between the client and the server. We see that we got back a 200, which means okay. That means our request was accepted and responded to correctly. So where is, and here's the word, foo. It retrieved the variable from the request, found it in the map, and outputted it. Now, you can also match against specific methods. So you could have the same pattern handled with different methods. So for example, you could have a method function that's handled with the get handler. You have the method functions handled with a put handler just by having this little decoration on it here. So you could do something like, so here I'm specifying we're using the get method using curl. And we're calling the method endpoint, and it says hello get 200 okay. But if I instead use put, it calls hello put. So we can match that way, which is actually very, very powerful, particularly in RESTful services where you can have the same pattern, the same endpoint that you want to execute different actions based upon the verb, the method that you pass to it. I also want you to see this. Here we're asking it to use the delete method, HTTP method. This doesn't exist. It's not handled. So we get a method not allowed error, which is to be expected because we don't handle it. So,
Right.
Do we have any questions about this?
Yeah, so we have other Go questions if you want to take them.
All right, bring it on.
You should be termed like the brand ambassador of Go after this live stream. So yeah, where does Go fit in since we have good framework and support for language like Node and Java? When do we go for Golang instead of other languages?
Go is really great in a lot of different ways because it compiles into an executable binary, which is super powerful. So that's just one of its advantages. It's also fast with speed comparable to something like Java, not fast like Rust. Rust is a whole other use case. It's also a beautiful language, but that's a whole other set of use cases. It is compiled as opposed to interpreted, which makes it much faster, which also means that you'll catch a whole other class of errors at compile time as opposed to at runtime. For example, if you are writing Python code, you accidentally use a string as an integer, you don't know until you actually try to run that code very often. And who hasn't tried to do that? I mean, I've done that before. So going back to the first point, that Go compiles down to an executable binary, that is super powerful because it means it doesn't need to carry around its own framework. So if you were to run something like Node, or if you were to run something like Python or something like Java, you need the language runtime to come along with it. You can't just drop Node onto a machine. I mean, you can have, there's all sorts of wacky stuff, but for the most part, you can't just run Node on a machine as a binary or Python or Java. You need the runtime. You need the runtime along with it. Go eliminates that necessity, which is really, really valuable in a cloud native context.
Right. So another question, going by the syntax, development in Go looks pretty similar to Node.js. Is there any difference that separates Go from Node?
I think the similarities really end at where the commonalities in the syntax. Node.js descends from JS, which is a Java derivative, which is influenced by C. Go is also influenced by C. So they have this kind of common ancestry, so to speak.
Right.
But Go is compiled. Go has, again, it compiles down to a distributable binary. It has, it's garbage collected, but so is Node. It's not interpreted. There's lots of differences.
So like I'm just curious, how many programming language do you actually know, and like how many have you are you familiar with?
Oh my goodness. I started with LPC. I've written some PC assembly way back when. C, C++, Java, Go, of course. Pascal, if anybody remembers that. Yeah, there's a few, but as you learn languages, you start to see the commonalities between them, and it becomes easier to pick them up. Like learning natural languages, it's once you
Right.
learn one or two, it becomes a lot easier to pick up more.
Language is more like a like it helps you. It's important to like be able to ideate. Language is just like a medium to show the idea, right?
Exactly. A language is just a tool. So like any other tool, and you want to pick the right tool for the right job. So if the tool or the situation rather calls for using something like a node, reach for that. If you don't know the language, learn it. It's you can learn anything. If the tool calls for something, or the situation rather calls for something like a Rust, or something like a Go, or something like a Python, choose the right language. And I can't emphasize it strongly enough. Even though I'm a big Go advocate and I really love the Go language, and I think Go is very, very useful in a lot of contexts and a lot of cases, particularly the cloud native context, there are very few languages that are, actually there are no languages that are superior to all other languages in all other cases. So I want to make sure that I communicate that. That's something that people often don't figure out until they become very senior in their career.
Right. Okay. So yeah, so you can see the project later on GitHub. Matthew will upload the link in the comments as well later, so you can go and like, click on it and then refer to it uh, while you're watching the live stream again.
Yes.
So yes, I think we can move forward for now. There are one or two questions that we can take for later. Like
Okay. And I will find that GitHub for you in a minute. So, okay, moving along. We have, as we saw here, 3 handler functions, 3 different situations. Moving on. Now we're going to take all these pieces together. We're going to build ourselves a RESTful service. We're going to review HTTP methods that are common, or which ones we're going to use. We're going to lay out how we're going to use them, and then we're going to implement our create, read, and also our delete function using the core API that we created in the very beginning of this live stream. So, for those of you who aren't familiar, HTTP is an interchange protocol that has a lot of different methods to it. Each one has a different meaning to it. Most commonly used are things like get and post. As you browse the web, you'll use get very frequently. If you want to submit information, you use post very often. The ones used most commonly in RESTful services are get, put, delete. Sometimes post is used, but generally what these have in common is that they're all idempotent. If you're not familiar with the word idempotent, it's very useful in, especially in the cloud native world, and I can dig into why that is at a later point, but it essentially means that if you execute an idempotent function once, if you execute it again or again, you'll have the same result as you do the very first time. So the 3 methods we're going to be using a put, which, as you might imagine, we'll be using to insert a key value pair into our key value store. The status codes that we can get back from this are 201, which means created. If you're not familiar with HTTP status codes, I encourage you to go look those up. They're very, very useful. They're very, very, they're something you really should be familiar with if you're building web services. The second method we're going to implement is get, where, as you might imagine, reads a key value pair from the store. That could return two possible statuses, a 200, okay, or a 404, not found. I think we're all familiar with 404. And finally, a delete. The only thing that it can possibly return is a 200. Either the thing is deleted and it's not there anymore, or you try to delete a thing that isn't there and it's still not there anymore. It doesn't really matter. This particular service doesn't care. So going back, here is our super simple API. Here's the thing that we introduced in the very beginning of the live stream. Again, we have our get function, we have our delete function, and we have our put function. All they do is they wrap functionality around a little map. Oh, I dropped the parentheses. Anyway, they have this functionality that they back with a simple map. If you try to get something and it's not there, it'll return this error. Now, these map exactly to our particular HTTP functions. I happen to name them the same thing. They don't have to be named the same thing. I name them the same thing because it's easier to remember and because they're also very reasonable names to use. So for HTTP get, we'll be calling the get function in our core API. Put, delete, same thing. Okay. Our main method is going to look like this. I'll go to the code in my IDE in a second. We have our new router that we're creating, and we are using the two functionalities that we both saw before. Our variable, which is a key name that we're injecting into the path here, and they're mapped to specific methods. Going back to the code, I believe this is 5. Yes. So here's our key value store, and here's our service itself. I don't know why these are underscored, but this code is legal. Again, here's our main function. Handle funcs. Here's a key value get handler, which pretty straightforward. Does some stuff. It does what we did before, where it'll retrieve the key from the variables. If it doesn't find that key, it'll return this error. It'll return a specific status not found, which is R404. And the text it'll pass is no such key. I think it is something like that. If there's any other error, we'll return an internal server error, which, if you're familiar with the HTTP error codes, is an error 500. And then we output that the value. And we have this little log function here too, so we can see what's going on as we do it. This isn't necessary, but it's nice to have. I'll go to put in a second. Delete is very straightforward, where it has something very similar, where we get the key name, and then we just call delete on our core API. And again, if there's an error, we return a server error. Going back up to put, our put handler. Now this does something a little more sophisticated. Once again, we're getting the value of the key from the path. And then what this does is it actually reads the request body. And it does that using the IO core library read all function. Read all takes a reader, which is a structure that often is used. It's an interface used for reading input streams, basically. And you can pass it a reader, and this will retrieve the entire contents of that input stream. It'll place it into value, and then if there's an error, this error value will not be nil. So we check for that here. If this error value is not nil, we return our server error. This defer is interesting. If anybody here is not familiar with Go, then this will seem a little unusual to you. The defer keyword is used in Go to postpone a function call until the end of the function that owns it. So what will happen is that this particular input stream, which is contained in the request body, will be closed as soon as this function ends, but not before. So this function is deferred until the very end. And then the straightforward stuff here, we call put on our core library, we check for an error, and then we write this header that says, oh, this worked out really great. We get a 201, I think that is, and then we log it. So I know that seems like a lot, but it's similar themes over and over again.
Yeah, we can take a question.
Yeah.
So Michael asks, in service.go, is there any significance to the lowercase letters you use, like W, HTTP dot response writer? So, uh,
In
yep,
service.go, in which part?
line number 5, I guess.
Line number 5? No, not line.
Or it would not be. Yeah, that one. Line number
So
20.
what I can say is, you may have noticed, Michael, you may have noticed that some functions begin with an uppercase and some functions begin with a lowercase. Actually, in this case, all of our functions begin with a lowercase value. There is a significance to uppercase versus lowercase variable names, including functions, in Go. Go has concepts of packages. So in this case, we have a package that we're just calling HackerRank. It's main. We're not doing anything outside of it, so we don't really care. Lowercase functions and variables are only accessible inside that package. So they're essentially, you could call them private, right? Uppercase functions. So if you have something like this, that's what's called exported. So an uppercase function like mux.vars, the vars function is exported in that we have the mux package. The vars function is accessible from outside that package. So we can call that by calling mux.vars. Yeah. If we have the HackerRank package, you could not call directly key value delete handler because it's not exported.
I think he also meant about like the W lowercase letters that you're using, I think.
Where am I using W's?
Like after
this. I see in the print line. Yes, thank you. Yes, there is a significance here. So you'll see format.f print line. Now, the format fumped package is used for outputting strings. So commonly you'll see fumped.println, which will print a string to standard out. But you can print to any string. So for example, we have the f print line, which can write to W. W is our response writer. So what that's saying is, here's our response writer. We pass that writer to the the fumped.f println function, and then value gets written to that writer. Does that make sense?
Yes, it made sense to me. Michael, if you have any other doubts, you can ask in the comments. And another observation is differ like await in Python for concurrency.
No. Go has a lot of other concurrency keywords. It's actually extremely powerful in concurrency. Defer is more like a in Java, it's kind of like a try catch finally. It's more like a finally. Like, here's a thing that'll be run at the end of the function no matter what. So if however you return from that function, as long as you don't have a crash or a panic, that defer will be called. It's typically used for cleaning up, for closing streams, removing locks, that kind of thing.
Okay, cool. Yeah, there are a few other questions, but we can take them after you proceed for a while.
Okay. So let's see this in action. So I am in 4. I want to go to 5, and I'll run this. So this is our full service. This is everything. So we could do something like curl localhost 8080, and the path we use is v1 for version 1, and then we'll call this key A, and this will return a 404 because this doesn't actually exist. This is calling a get, and we'll see 404 not found. So instead, we have to put that value, hello key value store, into localhost 8080 v1, and we called this key A. So now we're calling curl, calling the put function. Here's the payload, and it's going there. So we've got now a 201 created, which is exactly what we wanted to see. And if we call the get again, we'll get hello key value store. Now executing the deletes. So we can do delete of the same thing. Got a 200 OK. Now item potency means that if we execute it again, we'll get the same value, which we have. We got a 200 OK. So now we know it's doubly not there. And if we do a get, here's the get, we now get a 404 not found because we deleted that value from our key value store.
Right.
Okay. And I believe this is just the methods that we used. And here are the commands that we called. And that's really it. That is the end of the demonstration portion.
That was an excellent demonstration. I can't wait to follow this live stream again and then build it out by myself. And I'm pretty sure the audience here is very excited as well. Like Deepak, who really enjoyed the live stream and he wrote very nice session. Thanks to the team involved in conducting this event. But major thanks to Matthew who was here. So, he's still here for around 10 to 15 minutes more. So if you have any other questions, you can ask him now because this is a very good opportunity to get answers from him one is to one. Right.
Happy to take any questions.
So we have a few questions. Right. So Vidya asks, can we mock RESTful APIs built using Go for unit/integration testing purpose? If so, could you name few mock frameworks?
Oh, that's a great question. That question makes me happy. Yes, you can, in fact, and the Gorilla Mux framework actually has a large testing capability for doing exactly that.
Right. So, are there any other recommended testing frameworks?
Go test. I mean, Go test is the core functionality. Let me actually show you real quick. Building unit tests doesn't really require a third-party testing library for the most part. Like, for example, this is the native Go test that I use to test the core functionality, which we saw before here. Delete, key, delete, get, and put. And this just is exactly this. It uses, oh, this is the wrong package here. Anyway, so all this is doing is exactly what it looks like it's doing. So there's a function called test put, and then I can go to and run go test, go mod init, this is, and then go mod, here we go. That's all set up now. So if I do go test, it runs all my tests. So it's actually compiling the Go binary, and it's ran all the tests, and they all passed. This is part of the default out of the box capabilities of Go. So there's a robust testing capability. Definitely encourage you to go look at some of the documentation around that. It's
Right.
actually very powerful. It does benchmarking and all sorts of other things as well too.
So another question, does Go support reactive programming?
Could you define reactive programming for me, please?
Yes, Malcolm, if you could give more context on that. Till then, we'll move to the other question. Is Go also useful for automation tester or software development engineer in test role?
I'm not going to say it's not useful. It is a very useful language, and I really enjoy using it in the automation context as an SRE. That's something I do an awful lot of. And the reason I find it so valuable in automation is because I run a lot of these automated functions in different environments. And because Go does compile down to a single binary, it lets me distribute my code very easily. If that's something that you would find useful, that's something that may be valuable to you as well too. However, if you are doing more like rapid prototyping, if you're writing stuff that are more like scripts, an interpreted language might be more appropriate. But again, that'll have to be the determination that you make based upon your requirements at the time.
Right. So I think this is like a wrap of all the questions. So I would like to just end the live stream with a question from my end. That is, we could see like a lot of people have started to learn Go and they were asking a lot of questions on Go. So let's wrap this live stream with probably your top three advice for like someone who's just starting out with the Go language or with, like creating a backend service or like learning this technology for the first time. So what would be your top three advice for them?
Look at other people's code. Look at existing projects. Go sometimes surprises people because it doesn't have magic. It doesn't have much magic, at least. People coming to Go from Python, for example, are distressed sometimes because you can't have things like annotations. But Go is designed to be maintainable by a lot of people. I don't know if anybody here has ever had to maintain a large Python project. It's very, very, very difficult to keep everything in line. Go makes it very, very straightforward. So keeping in mind Go's design intentions will be very, very valuable for you. That's one thing. Look at other people's code, keep the design intentions in mind. And this is true of any language. If you're coming to Go from another language, try to do your best not to write Java in Go or Python in Go or Node in Go. It'll be very tempting to try to use the idioms that you're familiar with in your first language, in your new language, but you'll find that things don't work quite as well as you're accustomed to in the new language that way.
Right. So I really enjoyed the live stream. I think it was a very knowledgeable session. If any of you have any other questions, you can reach out to Matthew on LinkedIn, and then he'll be happy to answer all of your questions. And if you want to follow this project on GitHub, not an if, like you should follow this project on GitHub. So you can go on this link and then just like just are there project materials also there? Like the slides are also there, right?
No, but I can put the slides there.
Yep.
I'll put
And
them there right.
sure, and everything that you coded is already present there.
Yes.
Okay. So if anybody else wants to contribute to it, I'm pretty sure like Matthew will be happy to, like take any questions also.
Absolutely. It would be my pleasure.
Right. So I think a lot of people really enjoyed the live stream. This user will definitely give Go a go. So yeah, I think everyone should give Go a go. And any closing thoughts from your end?
I just wanted to say thank you to everybody who watched both the live and the previously taped version. Everyone who's here, everyone who asked questions, everyone who was in any way involved, I really appreciate it. Thank you so much.
Thank you, Matthew, for doing this live stream and then taking out time from your day to trying to teach something new to all of us here. And I'm pretty sure like everyone really enjoyed because I definitely did. So that's a wrap on the live stream. You can stay tuned for more, and then you can also follow Matthew because he you keep on doing talks and live streams, right?
From time to time. Yeah. Yeah.
Right. So probably this will be like a motivation to do more because you're in. Uh, so yeah, you can follow Matthew and then attend his other live streams as well. So that's it. Okay, we'll see you for the next live stream.
Thank you so much. Have a great night.